So good evening. I'll be talking about identical servers in production staging and development using Chef AWS and Rigor. We'll be discussing those more later on. So I am Christopher Rigor. You can find me on Twitter and GitHub at Rigor. I work for Engineered. It's a platform as a service company. We support Ruby, PHP, Node.js, and soon Java. So I'm an application support engineer and the team lead for the Asia Pacific team. So this talk is based on our experience in building our platform, but it's actually generic. Like you could use it for your own stuff. Like you don't have to be a customer for engineer to appreciate what we are doing. So we will begin with production. So if you have a site available somewhere in the internet, then you have something in production. So I'm going to talk about different setups for production. So for simplicity's sake, you start with an app server. So these are servers: an app server, and then an app server and a EB server. So on your app server, you'll put your application code: Ruby, PHP, Node.js, Java, Python, .NET, anything, and it will just connect to your DB server. It could be Postgres, MySQL, Oracle, or whatever you're using. So then if you get more traffic, you add more servers, then you have two app servers talking to your database server. So there's no limit. You could add more app servers. Then you could also add DB slave for replication, or you could use it for reporting and or for to have your apps connect to the slave for reads instead of the master. So to distribute the load basically. So it also doesn't stop there. If you have a complicated website, a complex website, you might have other types of servers. You might have search. Like if you have search functionality, you don't usually use your database for that. Like you get the data from your database, but then you have a separate process. It could be Solar, it could be Sphinx. Then you might have background workers. In a typical website, when your user clicks something, then you want it to return as fast as possible, so that he doesn't wait. So then you could put some of your extensive work on a background worker. So example, if you're uploading an image and you're storing that image to a separate location, you don't want your customer to wait while it's uploading to the separate location. So you want a separate worker to handle that, and then you have your so you could have your own server just for that. Then to make your site faster, you could have cache servers. Here you could use Memcache. You could use Redis. So instead of heating the database, you'll just heat your cache, which usually uses memory and doesn't have to heat the disk. So, in production, you could have a simple setup, or up to, sky's the limit, like how much you could afford. So you could have any number of servers. So when I mention production, I actually talk about AWS, or Amazon Web Services. So who here has used the Amazon Web Services? So the company that is popular for selling books or for selling anything on the internet is actually also renting out servers. So if you want any number of servers, you could get it from them. So it's actually a good story how they came up with that. The same Amazon company is behind this AWS. So when I talk about EC2, when I talk about the servers earlier, I actually talked about EC2, which is the Elastic cloud compute. So these are the servers from Amazon, so they call it instances. So this app server and DB server, these instances, you get them from Amazon. So aside from EC2, we also have EBS, which is the elastic block storage. So you put your data, if you have persistent data, if you want your data to persist among different, if you're going to save your data and reuse it, you want to put it on the EBS. So here in our platform, when we attach an EBS volume, we use /data. That's just a convention that we use. So the code, your application code, ends up on /data. And why is that important? When these EBS volumes, you could take snapshots of them. So when you create a second app instance, you don't have to start from scratch. You could copy all the data from the first server, and then you could attach that to the second server. So now you'll have different EBS volumes, but since that's created from the snapshot, it would contain the same code, same files. And the snapshots would be your backups as well. So you could take snapshots regularly and you'll have backups of your code. So it's the same for DB. We just use a different, different location. We put it on /DB. Yeah, we have EBS volumes for the app servers and from the DB servers. So and then in addition to the snapshots for the database volumes, it's not a replacement for for running MySQL dump or Postgres or data dumps of your data. So it's just another, layer of protection for you if your existing data gets lost or you lose data. So yeah, so this is the setup that we usually use. So Amazon has a lot of different services. Like they provide different stuff, but on the most common things are EC2, which is the servers, and EBS volumes. So yeah, this is production. This is for live traffic. Like if you have a site, you have servers for the live traffic, and you have a staging environment. So I do hope you don't change your code straight away in production. It could happen. Like we're in a hurry, you see a bug, that could happen. But for example, here you have two app servers. You have to make sure that whatever you're changing, you change it to both. So anyway, so on staging, you use it for the new changes that you want to, for example, present to your clients. Like you don't want to put them straight away to production. So so the way we do it is, so you have your existing app servers, you have your existing database servers. So you have the data volumes and then /DB volumes. You could create snapshots of that, and then create new servers, and then attach the volumes, the new EBS volumes on those new servers. So with Amazon, with AWS, you could create snapshots of your production environment and get the same number of servers to use as staging. So you have the same setup. So if you have separate DB and DB slave in production, you have the same setup in staging. Like you want it to be similar, to be the same as much as possible, since you want to be testing your changes on the same setup as your production is using. So you could use the staging environment for permanent things, like again, if you have a lot of changes, like if you have a client, he always wants to see the changes. Like you have a permanent staging environment when you were to put all your code in there before you put it in production. But the way Amazon works is you pay for the servers per hour. So if you, for example, need to do load testing, you could create a staging environment for your production. For example, here I'll create the same number of servers. But if I'm doing load testing, like if the customer says, well, someone's endorsing our website or someone's tweeting about it, so we'll have much more traffic than what we're having now. You don't just pray that the number of users would not take down your site. Like you could create a staging server, you could boot up 10 more servers, and then you could do load testing. Like same setup, you could do load testing, and then you could stop the servers, and you'll only pay for 1 hour, 2 hours, even 1 day. It's cheap compared to what you'll be achieving. So yeah, production, staging, you'll have the same setup. So where does Chef comes in? Like, so this talk is about Chef, AWS. So where does Chef comes in? So when you build a server, so let's skip one slide. So when you build a server on AWS, you have a base image, which we call AMIs. So you build the server based on a base image, and that image contains all the software that you need. For example, if you need your web server, so let's go here. If you need your web server, let's say Apache, Nginx, it could be installed on the base image so that your server could have that right away. Then you'll have your app server. If you're using Ruby, it would be Unicorn or Passenger. If you're using PHP, the latest PHP FPM. Some use maybe Fast CGI. But the problem is when you're working on a website, you know that things change very quickly. Like Nginx would release a new version, you'll need a new feature. So you can't always create your base image because it takes time. So that's where when you need to install something on your server. But you don't want to do it manually, because what if you have 100 servers, you don't want to do it manually. So Chef you could use Chef as an automated tool to create to install the packages that you need. So just going back to the slide, you could do something like this. Just put this code and then run Chef. It would install version 1.2 of Nginx. So if you need to upgrade, just change the version, change it to 1.3, and then run Chef, then your servers would be updated. So that's how we use Chef and AWS to build servers and keep them updated. So when I talk about Chef and AWS, the code doesn't necessarily get included in that scenario, because your code, as much as you want to change your software, your packages, you update your code much more often. GitHub, for example, says that they deploy multiple times, like 40 times a day. Like on a single day, deploy multiple times. So you don't want to create new servers every time you deploy. So the code is not tied to the Chef and AWS, cycle. Like you have different tools. Like if you have if you code in your local machine, normally what you do is push your code to a repository. It's somewhere out there. It might be on GitHub. It might be in your own machine. But from your local machine, you push your code somewhere in the repository. And then what happens is your app server pulls the code from the repository. So this is the normal scenario, and there's nothing wrong with that. So development, there's nothing wrong with that workflow, but there could be a few problems. So if you've encountered a problem wherein it doesn't exist on your development machine, but it exists on the staging server or on the production server, you can't tell your client it works on my machine. I don't care that it doesn't work there, because what's more important is it works in the production environment. So the solution that some people do is, like, I love my Mac, for example, but I won't use a Mac server to put my web stuff on it. So we use Linux, and some people would use Linux for their development, and that's fine. But even using Linux for your development is not enough, because the desktop version would be different from what you're running in your servers. So here, what we use is virtual machines. So in this computer, I could run 2 more virtual machines. They could be Linux, and they could have the same setup as my servers. So I have my Mac, I could develop on it, but the servers would be running, but I'll have servers, virtual machines running inside. So so it's not actually just, so the main purpose is to have identical setups. I mean, it's one of the advantage, but it's not the only use. For example, if you have a new developer, what happens when he starts is he needs to install everything. So if you have a virtual machine, he could actually start on day 1, put a virtual machine, and everything would be installed. Like the guy next to him would be using the same stuff as the new guy. So another advantage is using one VM or one set of virtual machines per app, because it's very much possible that you have you're developing multiple apps, and one uses, for example, MySQL version 5, and the other uses MySQL 5.5. And on your development machine, you wouldn't want to install both of those versions. In fact, you might be using a version different from those two. So this is another solution for that, so that you always use the same version as your production. So we achieve this using VirtualBox. So the virtual VMs that I mentioned, they're actually provided by VirtualBox, which is from Oracle. The VMs are free. Even VirtualBox is free, and then you could get the VMs for free. So, and you could install VirtualBox on Macs, on Windows, and on Linux. So that means you could have Windows, you could have Mac, but you could also be running Linux VMs. So it doesn't matter what your personal environment is. You could have a copy of your production there. So Vagrant is just a tool to manage VirtualBox. So the problem with VirtualBox is you have to install the VMs yourself. You could import and export it, but most of the time you have to install it. Like you could have your ISO or your CD installer, then you'll install it. So what Vagrant does is it provides a way for you to distribute, to share your VirtualBox. So someone out there would create a box for Debian, for Ubuntu, for Gentoo, for CentOS, and you could use that. Like you could just run one command and then just use that box. So you don't have to install anything. You just run that command and you'll have your own VM. So to recap, you could have your identical servers using Chef, AWS, and Vagrant. So you have your production there, you could clone it to staging, then you could have your VMs in VirtualBox. So disadvantages. So it's not all, it's not all rosy in the Vagrant land or VirtualBox land. As I said, you need to install your OS, or you need to find boxes. So it's not easy to find the box that you need. For example, you don't know how that Debian box was built. Like, it's possible it was, I'm not saying it could be malicious, but you don't control that. So that's one of the disadvantages of using Vagrant. So you have to put work to maintain your setup. So then, almost done. Alternatives. So the whole talk is about Chef, AWS, but it's not the only thing out there. So in terms of servers, Rackspace provide cloud servers. Microsoft Azure has VMs as well. And you don't need to use just Chef. There are others like Puppet, Ansible, or Salt, which I don't have experience. I just want to mention that there are a lot of tools out there. Then for your development, you could use VMware, which is not free, but you could use it. So you don't have to use VirtualBox. You could use VMware on your local machine. So that's it. Thank you for listening to my talk, and thank you to Smart. So you have similar setups. I'd like to hear about your stories and what lessons you learned. If you tell me your story, I'll buy you a beer tonight. So, so there are customers, so they're using engineers, so they don't count. So thank you. Again, you can find me Twitter or GitHub at Rigor. So that's it. Thank you.
Okay.